let's get started. Ann Elise Record, our presenter tonight. She's been an educator for over 22 years. She's been a classroom teacher, a math coach, a specialist. She is an adjunct faculty member at Plymouth State University and is currently a national speaker, an independent math consultant. She's one of the authors of the Fluency Doesn't Just Happen books. And I can tell you that she is passionate about her work with teachers, schools, and districts to help them implement best practices. And like I said, if there is one thing I can say about Ann Elise Record, it is passion. And so, Ann Elise, I am going to let you take over and thank you.
Great. Thank you so much, Mark. I'm so thrilled to be back here doing Brainingcamp webinars again. I just absolutely love them, and I love the Brainingcamp apps as well as all the people that work at Brainingcamp. In fact, I mentioned that Cuisinart rods are my favorite manipulative. That's what brought me to Brainingcamp in the first place, was that I had during COVID and the shutdown, I didn't have any jobs to do because all schools were closed. And I love Cuisinart rods. And Brainingcamp is the only virtual manipulative site that has the trademarked Cuisinart rods from hand to mind. And so that brought me to connect to the head of Brainingcamp, and then I began doing some trainings for districts during the shutdown. And so they've been phenomenally wonderful to me, and so I'm so thrilled to be here. So tonight we're talking about um, uh, decimals and building number sense with decimals. And so I was a grade 5 teacher for 13 years. And I became math coach K5, and that really did mark my time of really having in-depth understanding of the mathematics. I had been in my silo of grade 5. I know I did concrete and pictorial abstract explorations of the math concepts, but honestly, I was doing concrete and pictorial of the algorithms. I was using those to show why the algorithms that I was teaching worked. But I've now learned how much more flexible strategies there can be, and efficiency and accuracy, and how we can provide access in our classrooms for all of our kids, right? It's not just about certain kids. How can we unlock this math journey to create positive math identities and build the agency of our kids, that they believe that they can learn math, and also their agency, that they can show us with their actions, that they know they can figure things out and they can wrestle with it. And one of the biggest things that I used to complain about when my students had no number sense, right? They'd be asked to calculate a problem, but it was something that could be done really relatively easily as mental math. But the kids really weren't attending to the values of the numbers they were working with. And particularly with decimals, I know I didn't teach it in any other way other than, like, if we're adding them, just stack it together by decimal point and then use the algorithm we always do, and then plunk the decimal point in the bottom. But many times my students would make mistakes, and I would say, oh, they have no number sense. But then I did nothing to help them develop it either. So I live with Dr. Maya Angelou's quote that we do the best we can. And then when we know more, we will do better. And so I just live by that quote. So Christina Tondeval is one of my good friends. She runs a site called buildmathminds.com. And I love how she says, number sense can't be taught. It must be caught. We need to immerse our students in experiences that build their math identity, that build their understanding of what decimals are. What do they mean? We're not rushing to get answers. We're talking about not only answers, but how did you get that answer, and build that flexibility with all of our students. And so here's one of my favorite quotes by Howden on what number sense is. And I would ask you to read this. And then in the chat bar, could you put any words or phrases that are kind of resonating with you and that stand out to you on what number sense is? Oh, yeah. Yeah. Kimberly, capital letter is visualizing, right? Yeah. It's so important for all of our brains to expose the mathematical ideas in visual ways. Thank you. Yes. So many of you are echoing that of visualization. Absolutely. Every single brain can grow and develop its visual skills. I did not think I was a visual math learner. I was back in my training to become a teacher. Howard Gardner's multiple intelligence is a big thing, and I thought I have the math brain and the music brain. I don't have a visual brain. But it turns out that we all have a part of our brain that is visual that we can grow and develop. And I have built the visual part of my brain. So now I choose to enter tasks in a visual way first, right? And so that relationships also really key. Those many of you are mentioning the language we use. Absolutely, Rosemary. And gradually, right? This does not happen overnight, right? We're going to be building the understanding of our kids over time. Is going to happen numbers and their relationships to each other gradually by exploring and visualizing in a variety of contexts. So certainly the Brainingcamp site offers such a variety of manipulatives that we can explore, and they have work mats that are for decimal numbers. So to have the students be able to expose them to a variety of the physical models and the manipulatives, absolutely so important for all of our students. So I want you to start off tonight by thinking about this example here. How would you convince me that these two sides of the equation are the same? And also, how would you make your thinking visible? So I'm asking two things. I'm asking, how would you convince me that these two are the same? And then also, how could you make that visible? Visible is so key for all students. Super. So I'm seeing some suggestions. Number lines are being mentioned a lot. Phase 10 blocks, decomposing. And I'm also seeing some models mentioned, right? So I'm asking you two things. I'm first asking you about a strategy. How would you convince me that these two expressions are the same? Second thing I'm asking you about is the model. So strategies and models are different. Strategies are what we do with the numbers to be able to think and reason. The models are how you make it visible. And those models can be concrete, pictorial, abstract, verbal, and contextual. These 5 representations that we have from the Lesh model that I'll be sharing with you in a little bit. So some people are mentioning constant difference. And so what I want to make sure that I want to share with you is the fact that we can be using a strategy, and the constant difference strategy is actually where I am going. So those of you that mentioned that, that is where I'm headed, because I know in the past, if you had asked me this, I would have said I would calculate the answer of 5.02 minus 4.98, and I would get an answer of 0.04. And then I would solve the right-hand side, but that's a little easier for my brain. So I kind of know that's 400ths without having to do an actual solving of it. But I didn't know about this amazing strategy called constant difference. And I think it's life-changing. And I want it to be a choice for all of our students. And I want to make that visual, as it's important for every brain to see things visually. So this is from a share code document I'll be sharing with you in a moment, where I have the share codes for all the different things I do tonight. If you want to be able to use them, make them your own, you are welcome to. I have gone into the Numberline app, because Numberline also, I agree, is a wonderful visual model for this. There's a lot of research based on number lines and how beneficial they are for all students. It has its own set of research and suggestions. So you got to make sure your students are exploring with number lines. So I've gone into this work mat in the number line, and I changed it to decimals. And that's why I'm able to show the decimal values here. And so what I'm going to do is I'm going to put a marker on the 5 2/10. And I'm going to put a marker here on the 4 9/10. Now, I was playing around with it a little earlier of these rectangular ones, and I couldn't quite get that to work. So I'm just going to, for tonight, I'm going to make a rectangle just to be able to show this distance between the numbers. A lot of our students think that subtraction is the answer when you take things away. But we need to make sure they build the flexibility to understand that subtraction is also the distance between the numbers, because based on the numbers, I choose different strategies. If I were to thinking about like a 90 minus 12, I might take away 10, take away 2, right? But if it's 92 minus 88, I'm going to add up to find the distance, right? The numbers are telling me what strategy I want to go for. So I have to know about both of them. And this constant difference strategy can be life-changing, as well, because take a look at this. The distance between 5 and 2/10 and 4 and 9/10, what would happen if I add one more tenth to both of them? Right? The distance remains the same. We're keeping the distance constant. This thinking can be happening starting with our basic facts, going to multi-digit numbers, decimals, fractions. It just integers, like it unlocks the whole connected math journey of our students. So you've got to know about the constant difference strategy. And I'm using a model of a number line to make that visual to you of why that is able for us to do that. So crazy powerful for that. And again, number sense with the decimals, not having to calculate and follow steps and procedures. And then next one I'd have you think about is 1.5 times 18. How would you convince me that that's the same as 3 times 9? And can you think of a visual model that could help that be visible to show why that works? So a strategy and a model. Oh, look at that. Yes, yes, yes. Double and halving, right? It is such an incredibly powerful strategy that when we multiply, as long as we half one number, we can double the other. Now we're starting of double and halving. It can, of course, go into triple and thirding and quadruple and fourthing, but it's that being able to uh, think relationally with these. And the model that I love using for it is the area model. So I'm going to go to my share codes document that I'll be sharing with you just in a little bit. And this is just, I want to make it visual to you because you've got to know about double and halving. I want this to be a choice for all of our students. You can double and halve any numbers, but sometimes they get kind of wonky when you double and half. So I wouldn't choose it all the time. But sometimes when it works well with the numbers, it's like so exciting. So 1.5 times 18. So here I'm showing you the area model. It's a wonderful model that multiplication will always result in a rectangle. And when we're doing division, our job is to make the biggest rectangle we can, and we might have some left over. So the area model is so powerful, multiplication and division. So if you were to think about 1.5, 1 and 5/10 times 18 as one choice of strategies, I'm going to make down below, I'm going to get the markers. Why can I not get the markers down below? It's like below my screen. Okay, well, we'll do it another way then. You got to be flexible in life and in mathematics. I think is the key to mathematics in life. Okay, so here you have a matching up of the area of half of this distance. So what if I cut this rectangle in half and I scoot that area down below? I'm trying to make that half, right? So I cut this in half and I'm sliding that area over here to the left. So what would be the measurement then of this distance now? Well, it's doubled to 3. And then this distance of 18 has halved to 9. So this rectangle here is a double and halving, right? Showing how we can double and halve any numbers. And so a 3 times 9 being a 27, that is the area of what 18 times 1.5 is. So it's a way of exploring numbers and relationships. Then thank you, Scott. So the toolbar, I just can't see my toolbar down below with maybe of my sharing my screen. Good gracious. Or is it this the Zoom toolbar? Because it's not helping me be able to share what I want to do. I have not had this happen before. I don't know, Mark, if you can help me. I want to be able to annotate and write on here, but my Zoom chat window is hiding the pens down below.
Yeah, I don't know.
Ah.
I
Oh,
wonder.
now it got minimized. Now I think I'm good. Now I think I'm
Okay.
good. Yeah, phew. Good
I,
gracious.
I fixed it.
Good. Thank you. Yeah, thank you, Mark. All righty. So just wanted to kick us off there a little bit of these number sense, these strategies that lets us attend to the numbers and the values, but have relationships that allow us sometimes to change the numbers to be different numbers that are easier for our brain to be able to arrive at our answers. It's not having to follow the set procedures that I used to do, where I tell my students in fifth grade, they pretend the decimal points don't exist and then do all the algorithm and then plunk it in and swoop it to the side. Like there's so many other ways I know now that we can be exploring multiplication that provide access for all of our students. So with that, I want to go over some elements of number sense. So when we think about number sense, and if students haven't developed number sense yet, like what can we do to build the number sense, right? It's an intuition. So when I first read that definition of an intuition, I'm like, yeah, but how do I teach intuition, right? How do I build it in my students? And so van der Waals research in showing that there are 8 elements of number sense. Now we begin with these with whole numbers with our youngest kiddos, right? So the verbal counting, the object counting of items, the cardinality, knowing the last number that I say in a counting collection is the quantity that is there. Supertizing, telling at a glance how many are there without having to count. The spatial sense of being able to explore visually the mathematics we're doing. Knowing numbers one more, one less. Can I develop that 9/10 is a tenth less than a whole, right? Do kids know that? Benchmark of 5 and 10, and then decomposing, breaking apart numbers into pairs that make them up. When we develop these in our youngest kiddos with whole numbers, we have to do it all over again when we introduce a new set of numbers. So when you're introducing fractions, the kids have to do all 8 of these to understand what fractions are and build their fraction number sense. Are they verbal counting by fractional amounts? Are they object counting fractional amounts and being asked, so how many are there? Do they know the last number they say is that quantity? We want them supertizing with fraction and decimal images, spatial sense, exploring them visually, concretely. Do we know one more, one less of fractions, and the decimal fractions being, of course, that the tenths and hundredths, multiples of tens. Benchmark of 5 and 10 turns into benchmark of 0.5 and 1, right? Half and 1. And then decomposing, breaking apart decimal numbers into pairs that make them up. That's going to provide us the foundational key skills that we need to be able to unlock flexible strategies beyond procedures that we're doing with our kiddos. I want to let everyone know about this book. I just wish every single educator and pre-service educator would read this book. This is not just for special education teachers. These are how do we provide access in our classroom. It's UDL, the Universal Design for Learning. How do we make access in our classroom for every single student? Our neurodiverse students, our students with disabilities, our multi-language learners. How can we make the things we do in our classroom open up to be able to make sure all our students have access to it? Highly, highly recommend this. And in it, she mentions the importance of, for all of our students, of exploring these 5 representations and methods. So this is called the Lesch translation model. It's concrete, so the physical, right? I've always heard of concrete, pictorial, abstract. The contextual, putting it into a real life context, and the verbal, being able to put it in words. So important. We have all 5 representations, and you will notice that there are arrows, right? It's about connecting representations, exploring things in a variety of ways, a variety of contexts, and drawing those connections between them all. So I want to make sure that we are mindful of that. In our classroom, how can we be including this in our exploration of decimals to build the number sense of what decimals are? This is the link of the share codes for tonight that you're welcome to make a copy of it and then tweak it and add more as you go of what you would like. So this is it's a nice, beautiful PDF that they made. If it isn't a hyperlink, I guess I got to do the HTTP for it. Hang on one second. So I would just suggest that you make a copy of it into your own Google Drive. Oh, it did. Okay, good. So if you copy and paste it, sure. And you can just click on that link now as well. But make a copy of that. If you want to be joining in and hearing me listen while you're exploring on your own in Brainingcamp, certainly feel free. But let's go through some of these elements of number sense and what it looks like with decimals and what are the Brainingcamp apps that we have and the work mats of decimals that will allow us to do these. So here we go. Subitizing. How do we determine how many are there but help the students move away from the counting one by one. So here you'll notice, in case you are new to Brainingcamp offers the ability to make a share code. So you can put anything you want, go into an app, put anything on the screen that you like, and then once you have on the screen the way you want it to be, you create right here. You say share code. You click on that and you just say, I want a share code. And you'll see there'll be a share code generated right here. You just copy it and just make a note of it. So what I did is I would make an Excel spreadsheet and I'd have the topics that I want to do and I keep track of the codes that I make. I don't want to have to reinvent the wheel every year. And so keeping track of that, it's super helpful. And so here we have the supertizing. I want to show you some dots. And what I'd like you to think about is not only how many dots are there, but how did you see it? Again, two questions. How many dots did you see? And how did you see it? So here, I'm using a hiding tool right here. So beneath this hiding tool will reveal the image. How many do you see? And how do you see it? This is an example of how I might do a number talk in a classroom where I show these dots and I ask the same thing I asked you. How many are there? How do you know? But as you look in the chat and you see, we all see it in different ways. Even if you see it as 4 and 4, you may have done 4 on the left side and 4 on the right, and someone else did 4 on the top and 4 on the bottom. We all see it in different ways. We all have the same answer. We all know it's 8. But how do we see it? We see it differently. This message that mathematics is not just about getting one right answer in one somehow correct way. One way does not work for all our students. Our students are complicated human beings. So we need to have a variety of ways to be able to help all of our students have access, right? And what you're just doing right now is supertizing. Those of you that are finding chunks of the numbers are supertizing. Our brains can supertize 5 and under scattered objects and be able to know how many are there, 5 or less. But once it goes beyond 5, even as adults, that's true. Once it goes beyond 5, our brain can't tell how many are there at a glance unless our brain begins searching for smaller clusters that we can supertize. So this one skill has been shown in early numeracy research, Duncan's article, 2006, I believe, to be a future indicator of both literacy and math success and future achievement. The skill, Joe Bowler calls it groupatizing. We're finding these groups of objects. Now, you'll also notice at the very bottom that I have a sentence stem. I know there are blank number of dots because blank. This is what I learned. I've learned this for many years, but it just finally hit my brain to be like, I need to make sure I do this. Rachel's work was very validating in that way that all students is going to benefit having a sentence stem. Our neurodiverse students, to help them get started to explain thinking, our students, all kinds of literacy challenges they might have, having sentence stems will help them. So having the students repeat to you, I know there are 8 dots because I see it as 4 on the top and 4 down below, or however they see it. Really critical piece there. So that is what supertizing is. So now, how do we do supertizing with decimal values? Well, let me bring you into this next share code. This is about going into the base 10 blocks app, and we're going to go to the work mat that is decimals. So you'll notice in each of the apps that there are choices of work mats. And so here I'm in the base 10. So if I go back to the objects, you can see these here. In the bottom right corner, I have workspace. When you click on that, you'll see I'm on the grid one right now. I'm on the grid. And then I also chose on the bottom left the number set being decimals. So that's how you can change some of these apps to be the decimal values is right under here. They have you choose, well, what set of numbers do you want to use? And so I chose those. So once again, what if this entire square is a whole? So it's measuring 10 by 10, right? So hopefully we had that discussion that every column or row is a tenth, every square is a 1/100th. But how would you explain the portion of this whole square that is shaded blue? How might you express that and how are you seeing it? It's not just the number. How do you know? How did you figure it out? Now, this entire square, this grid, is going to be defined right now as the whole, which means that each of these little squares is a 100th. So yes, I agree that 58 squares are shaded, but if you want this to be a decimal notation, that would be 58 hundredths, right? The whole thing is the whole. So this one is the base 10 blocks. And I've gone into the workspace called grid. So this 100 squares is already there. And I've also changed in the bottom left the number set to be decimals. So, all right. So how did you know? How did you see it? Well, so Lisa says that this is 200ths less than if the entire row was filled, and that would be 6/10ths or 60 hundredths. So you can think about it's missing a piece. Though if it were all blue here, that would be 6/10ths, but it's missing 200ths, so that would be 58 hundredths. Wonderful. Another person, oh, sees 2/4, right? So this up here, 24 hundredths is in this quadrant. Another 25 hundredths is here, so that's 50 hundredths. And then you might think this length here, well, it's a grouping of 5 and 8. I drew in these red marks with the rectangle tool. So under shapes, you can draw a rectangle, and I made it really skinny, and I changed to fill it with red so I can visually see it. Again, our brains can't subitize beyond 5. So if I have a row of 10, now I can subitize the 4. So if I know pairs that make 10, I can think, well, this must be 6 because that's 4. But I also like sometimes to mix it up and put these benchmarks up the halfway to help the kids kind of have that benchmarking as well. So again, sentence stem. I know 58 hundredths is shaded blue because I saw half of it is shaded in completely, and then there were 8 more hundredths. So that's 58 hundredths. However, the students can be explaining their thinking and how they knew it, but they'll see it in a variety of ways. But letting students have this opportunity to subitize with decimal amounts is part of building the number sense of decimals, right? Super. So subitizing is something that you'll want to do as a quick energizer, beginning your lesson showing visual images of decimal amounts. Now, the spatial sense of number sense. How can we explore in visual ways, visual, pictorial, abstract, contextual, and verbal, all the 5 representations? How can we explore the relationship in our base 10 number system of each place value position being 10 times the one to its right? So let's go and take a look at that. How can we visualize these place value positions? So what I have here is a listing of like a place value chart down below. I typed these in. I'm on the workspace here of just the basic workspace in the base 10 blocks. And here I have the ones and a tens position and hundreds and then the 1000s, right? And that is what typically we do. Now you're not having to make this little cube be the ones. We don't have to be locked into that. We can be flexible because there's a relationship. Each one of these is 10 times the one of the others. So we could define the whole of being any of these. It's up to us and thinking about those relationships. But typically, of course, we are used to experiencing as the cubes are the ones, the rods are the tens. Here we have hundreds, and here we have thousands. And my question to you is, what do you notice? What do you notice about this visual representation of the ones place, the tens place, the hundreds place, the thousands place? Yeah, we got 1 as a value at each of these place value positions, right? Absolutely. They certainly are getting bigger. And I'm curious, how much bigger? Much bigger, let's say, is the rod in the tens place compared to the one in the ones place? Or the hundreds place compared to the tens? Or the thousands compared to the hundreds? Yeah, right. It's 10 times more. Typically in our state standards, grade 4 is the year we begin talking about 10 times bigger. As our place value positions go to the left, it's 10 times the one to its right. In grade 5, we tend to do the One of the standards is we do the 1/10, the one to its left, right? So explore both ways. But yeah, right. Our number system is based on the number 10. It's a multiplicative relationship. Every position is 10 times the one to its right. So I'm going to ask you this now. So this is another question I have for you. I'm going to reveal. What would the 10,000 look like? So you're seeing the ones, the tens, a hundreds, and a 1,000. What do you think the 10,000 would look like? So I told you I taught grade 5 for 13 years, and I had base 10 blocks in my classroom, and I wanted my students to see the 10,000. So I went to a company online that sells cardboard boxes, and they measure very similar in size to the physical manipulative of the 1,000 cube, and it's 10 of them, right? Like it's 10 times bigger. So look at the ones cube that's yellow. See how in the tens place, 10 of them get stacked like a rod? That's what would be in the 10,000 place. You would take 10 of those green 1,000 cubes, stack them 10 tall. It's another rod, but it's immensely bigger than our tens rod, right? Because it is 10 of the 1,000 cubes. So what would be the 100,000? What would 100,000 look like? And I built this with boxes in my class. I bought the box that is by 1 by 10. And then you can take 10 of them. It's going to be like just the orange flat, only each of those cubes is the size of an obnoxiously large flat. It's so true, right? It's going to be huge. So we have the 1,000 cube. We have a stack of them as a rod, 10 of those tall. Then you have 10 of those tall things left to right of 10, like a flat. And then you put that flat on the floor and you stack it 10 times big. And that's your 1 million cube. 10 millions is 10 of those like a rod. 100 million is 10 of those like a flat, right? This is a pattern in our number system of the ones, tens, and hundreds. It allows students to visualize the place value positions. So with that in mind, how do we transfer that to decimals? Well, it's not going to be, I'm not going to use the ones. It might blow your mind a little bit. I'm not going to make the ones be the little 1 cube because I can't break that apart into 10 pieces. Okay. So instead, just for the sake of exploring this tonight, what if we have the cube that's that 1,000 cube, right? Can I break that apart into 10 pieces? What would the 1/10 look like if this were the whole, right? 10 of them have to make the whole. So there's your flat. And what would it look like if I'm in the hundreds? Well, it's 1/10 of the tenths. That's where you get your hundreds. And then what would happen here in the thousands? Right? I'm down to a cube again, right? The pattern continues getting infinitesimally smaller. So just to be able to kind of visualize this pattern in a number system, every place is 10 times the one to its right, and every one is 1/10 the size of the place to its left. Visualizing these place value positions is really powerful for our students. Really, really important. So, all righty. So we talked about the supertizing, the spatial sense. I accidentally skipped verbal counting. Let's go back to the verbal counting. I was like, where's the verbal counting? I accidentally skipped it. Let's go back to the top for verbal counting. How do we have our students counting by decimal amounts? So this is from a wonderful book called Choral Counting and Counting Collections. It's a phenomenal book. I highly recommend it. It's for all ages. It is not just for choral counting and collections is not just for young kids. It's also at your levels as we build decimal understanding. So I am in here in the Colored Tiles app, and I'm in this workspace here, the basic workspace. And I chose to have decimal amounts. That's where you want to look down here under, it says whole numbers or decimals. So I chose decimals. And then you can have it, you can click on things and take them away. So let's imagine we're in a classroom And I tell the students, okay, today we're going to count by 200ths, and I want us to start on 200ths. And then you can write them down. And I've this the way this is already set up here is to go left to right, and then the next row left to right. But you can choose to do this in a variety of ways for your students, of either going down in a column of 10 if you want to. It's up to you. Play with it, and different patterns emerge. So there's no one right way of doing it. But here within this app, you can see if we were to have orally counted together all of these, counting by 200ths each time, the kids will pick up on the pattern. It's increasing by 2/100ths. Now, once you're done, though, you're getting that oral entry of the words into the brains of the students by orally counting by these amounts. Now we look for patterns. What do you notice? What do you notice? And then you would annotate what you notice. Anything in the chat of what you notice? Oh, the hundredths digit is the same in each vertical column. Isn't that interesting, right? That is staying the same. The hundredths position is staying the same. They're all, well, I understand you're saying they're all even numbers, but they are decimal amounts. But if we think about the number of hundredths, there's an even number of hundredths in each of these. Absolutely. The tenths place is increasing by 1 as it goes down. Interesting, right? So many patterns emerge, and it's again building the number sense of our students. So it's a choral counting activity where you're saying the numbers out loud. I do this with fractions. I do it with whole numbers. You choose where you want your intervals to be, right? But you're noticing the patterns that are happening in the number system. You also can then predict. So you could say, what number will go here? Now, there might be some students that will still skip count by the 2/100ths, but look at the column here, right? It went from no tenths, 1/10, 2/10, 3/10, up to 9/10. Now it's going to be 10/10. So 1.06, right? 10/10, which is the whole. So you can be predicting ones based on the patterns that emerge as you do that. So Chelsea, I actually mix it up. I do it in this way, but I also do it where I have the column come down as we count. So it's about becoming flexible, building that number sense, and thinking about the relationships, and then noticing the patterns that happen. So yeah, so verbal counting, really, really powerful. Also, I've done here too is I've done an activity of like missing numbers on a hundreds grid. So if you were to come back in with this share code, then on the screen, I've clicked some values, but you have students choose, well, which box do they want to figure out what the number is? And then if they click on it, they get that immediate feedback of whether they're right. So getting that timely, immediate feedback. And then, but again, encouraging the students to just discuss the patterns that are emerging and why those are happening in that way. So verbal counting, subitizing, spatial sense. Now we have the 1/10 more and less. So what do we do that helps students develop the 1/10 or 100th more and less? And that's about students visualizing number lines, knowing that when numbers are next to each other on a number line, it means they're 1/10 away from each other. So as an activity, you might have a number line here, and I would validate with the students that it's broken up into 10 pieces. There are tenths between 0 and 1. There are 10 of these chunks, right? And then ask, like, what would be on this one here? What would be on this? What number is here? Now it's 3/10 away from 1. 1, 2, 3/10 away. Now go back to my pairs that make 10, 7 and 3. Then that must be 7. Oh, I have my benchmark on the wrong one. Yeah, see, all well-intentioned and good. I wanted to have like a little hash mark for the halfway mark for 5/10. We all make mistakes, right? We learn and grow. So here we have this. I can click on this here, make the label beyond to see if I'm right. Is it 7/10? And I would encourage you to think about how far is that to the nearest whole, right? It's 3/10 away from the whole. And why would want to do that? What if I were to ask you 7/10 plus 4/10, right? And I told my students, line up those decimal places, add like you normally do, and then plunk that decimal point in the answer. But they were never attending to what they were actually doing, the values of the numbers. Instead, what I do is I have it horizontally now here, and I would say, how far away is 7/10 from a whole? Well, it's 3/10. And that 3/10 exists in the 4/10. I can break it apart and reassociate it. It's the associative property of addition. We start doing this with the bridge 10 strategy. Let's say adding 7 plus 4. I can think about taking 3 from the 4 to make a 10. And then there's one more left over. So I know I can rename it as 10 plus 1. It extends all the way through our different sets of numbers. So building number sense with operations. Just want to give you a hint of why the skill of thinking about how far to the nearest whole, to know that on a number line, that if I have 7/10 and 8/10, they're next to each other on a number line, it means that they are 1/10 apart. So if I were to ask students about 8/10 minus 7/10, it's just one apart, right? It's just 1/10. So whatever we can do to build and let the students see these existing on number lines, particularly, really, really important. All right, coming down to the last two number sense skills. One of them, talking about now, is using the benchmark of 5/10 and a whole. So as we come back here to increase this share code here. So using 5/10 and a whole to help us. And we are, nope, that's not true. Ann Elise, what are you doing? Just decimal comparison, not it's about thinking about comparing the decimals. And so if I have 1 and 33/100 compared to 1 and 4/10, right, I can build that concretely and I can have the blocks. It's not about either or, it's about both and having physical manipulatives and these virtual manipulatives, particularly our students who are older that may think that manipulatives are babyish or not okay, which they entirely are. If I could run the world, math world, I would have a baggie of manipulatives with an arm's reach of every student at all times, at all grade levels. It is a choice to enter a task visually. I'm not going to leave it there. I'm going to connect it to pictorial and abstract and contextual and verbal representations, right? But that's important of these multimodalities to provide access for all of our students. So again, I have a sentence stem here. I would then build these amounts. So if I build that 1 and 33/100, right? I can leave it right there in this comparison mat in here. And I'm going to have my 33 as I'm building it concretely. But a lot of our students think that, well, this one must be bigger because it's got a 33 and this one only has a 4. That's part of the building number sense of our decimal values. So I want to be, again, building it. What does it mean to be 1 and 4/10? And how do I know which one is more? And then you can do in the bottom, I kind of hid the comparison. I'm going to make it be decimals. I'm going to click on the decimals to make it show as decimals, showing as whole numbers right now. Yeah, there we go. So the decimal values, right? We have 1 and 33/100, which is less than 1 and 400. So again, I kind of like to hide the labeling for a bit, give the chance for the students to figure it out, and then to reveal, get that immediate feedback, whether they're right or not. So that ability to have that comparison of numbers, building the number sense with our kids. And then we have the ordering decimals. So I love Kristen Acosta. She's absolutely wonderful. And she has a wonderful site about clothesline math. I've linked to it to you on the bottom of the share code document, so you can find her website. She's one of many that do this, but I just adore Kristen. And so having this as an activity, I want you to imagine that we have like a string on the front wall of the classroom, and she has sets of numbers from preschool level up to all sets of numbers where you cut them out and they can hang on the number line. So I would just wonder if I were to put this 0.5 somewhere on the number line, where would you suggest that I put it? Where might I put the 0.5, right in the middle, right? Like we don't have any benchmark of 0 and 1 yet, right? So I could. So imagine that the students can't see all of these yet. So you're going to go do a sequence of revealing these one by one. So let's say we have the 0.5, and yeah, we'll put it right in the middle. That makes sense. We'll think about like 0 being on the left, 1 on the other. We could put 5.5 there for 5/10. Awesome. Well, now I get the 7/500ths. I mean, think about where would this go? Right. And now the students might say, well, we're gonna put it over here because it's bigger than 5/10. And in fact, they might know it's a quarter of the way from the 5/10 if you imagine one being at the very end. So it's about the talking and the thinking and the reasoning. There's not like right and wrong answers, but what's your reasoning? How do you know? Right. Now we have the 1/10. So yikes, that's gonna be way down here, right? Because we're at the early end. And I might at this point think about, well, would it help to put like a 0 on the number line? And so our 1/10 is just going to be, imagining this being in 5 chunks, and there the 1/10 would go. Great. But now we get 1 and 6/10. So again, the kids wouldn't see all of these right away. You could kind of introduce them one by one. And so what would happen then to our thinking if I'm putting 1 and 6/10 on a number line, trying to be relatively proportional, right? This is part of the number sense. Well, gosh, if 0.5 is here, then a 1 would be here and the 1.5 is way off it. So what if and these are just perfect because it's a clothesline and you have the folded pieces of paper, or you might clip it with a clothespin. Let's readjust it. If I put the 5 here, right? Well, then if that's 0.5, then the whole would be here and the 1.5 might be around here. So we're being proportional, but not ridiculous, right? Not actually measuring things, but just reasoning. That's the point of the reasoning. It's a little more than 1.5, right? And I've adjusted my other numbers accordingly, right? 99 hundredths, thinking about how that relates to 1. Where might the 1 go? We're going to put it slightly to the left, have the kids be able to articulate that. And then we have 1 and 59 hundredths. And again, that thinking about it's super close to 1 and 6/10, right? It's only 1/100th away from that. Some students might think it goes way over here because you've got a 59 versus a 6. So we're building our number sense with them, feeling free to build them at any time, draw pictures. I love using 100 grids to draw pictures of decimals because it's hard to cut things into 10 equal pieces and whatnot. So having decimal grids already for the kids, like either laminated for them to work on with a dry erase marker, but again, making it visual of these decimal amounts. So much thinking and reasoning that we need to do with decimals. So grade 4, you're it. Grade 4 is where decimals enter the world. And then we become calculating with them, which will be a different webinar. Today is the first webinar about the number sense. How do we build the number sense? And then once we've built the number sense, now we can do the operating on them in ways that make sense for them as well. So, all right. Now we're going to talk about decomposing. How do we break apart decimals in ways that can help our students then? So I shared with you earlier that 7/10 plus 4/10. I knew that there were 3/10 in that 4/10 that I could break apart and reassociate. But I had to know that a 4/10 could be broken apart into 3/10 and 1/10. It also can get broken apart into 2/10 and 2/10. So if I'm adding 8/10 to a number, I might take 2/10, right? I have to know the pairs that make 10, and I have to know the decomposition of all of them, right? All the numbers up to 10, so I can then embed it in this work with decimals. So I mentioned Cuisenaire rods are my favorite manipulative. I think they have the power of moving our students from counting phases of reasoning into additive, where we're using chunks of numbers, and then from additive into multiplicative, and then into proportional, like it follows the kids through the different sets of numbers. There are 10 of them. So if you have not seen them before, there are 10 Cuisenaire rods, and the color of them matches the length so that no matter what blue rod you choose, it's going to be that size. So the color is attached to the length of the rod. And so they're relational rods. So they are Cuisenaire rods invented by George Cuisenaire. They are trademarked by the company Hand to Mind, where Brainingcamp partnered with them to make their apps be identical to the look of what you'll buy on Hand to Mind. So they're the only site that can call them Cuisenaire rods. The other sites that have rods like this have to call them something different, and they're called relational rods. So our first part of our definition of number sense is to explore number and number relationships. these rods allow us to do that. They are relational rods, really, really powerful. When I first saw them, I didn't care for them because I love rainbows and they were not in a rainbow order. But it turns out there's a method to the color madness where these are grouped together in particular ways. So if you look at the ones cube here, I call it a unit, right? Because it's not just a one. It could be a 1/10. It could be a 1/100th. It depends on it could be a half if I want to define the whole as the red one. So using them with various sets of numbers is powerful. It's about the relationship they have to each other. The yellow one is worth 5 of the one. So it's your benchmark of 5, and your orange one is worth 10 units. And they're the same size as your base 10 blocks. So when I'm using whole numbers with students, I use base 10 blocks for the rods and the flats, but I have a Cuisenaire rod in the ones place. Because too often, if you trace the thinking of the kids using base 10 blocks, they're using the cubes. They are just counting those cubes. They're not thinking additively. They are counting. So I use the Cuisenaire rods in the ones place. Now, as we use them here, the 5 units and 10 units are hot like the sun. This is your 2 doubling to 4, doubling to 8. So related doubles of 2, 4, 8. And then you have 3, 6, and 9. So they're grouped together like the ocean colors of the blue and light green. And then you have 1 and 7. They're by themselves as their own kind of set. So knowing that's how Cuisenaire rods work and getting familiar with them, I'm now going to go to the decimal workspace of Cuisenaire rods. And I mentioned to you the importance of verbal, right, context. So Sally the seamstress had 6 1/10 of a meter pieces of ribbon that had a total length of 6/10 of a meter. If the pieces were pink and or purple, what are all the possibilities of the lengths of these 2 colors of ribbon? Well, I started here where, well, the total length is 6/10. And so one option would be that it would be all 6 pieces are pink and there's no purple. There could be another one where 5 1/10 pieces are the pink and then 1/10, one of them is purple. And I allow the students to explore in this way, and they can randomly be choosing and figuring out the different possibilities. But I do eventually want to do this in a systematic way so the pattern emerges. So I would say at some point, after they've explored and whatnot, now I say, okay, so what if all 6 pieces were pink? So 6/10 of a meter of that pink ribbon, that would be this one rod here. What if one of those pieces, one less, was purple? Then that would be 5 1/10 pieces. It leaves one of them being blue. And what if there was 1/10 less? Well, now I've got 4 of the pieces being purple and 2 1/10 pieces. So 2/10 of the ribbon is blue. And then I have one less tenth. I've got my 3/10. Oh, and my other 3/10. And then I have one less is 2/10, matches with the 4/10 because this is a different context. Commutative property of addition, we can change the order, of course, but the context is different. This would be 4 of the 1/10 pieces are purple and 2 of the 1/10 pieces are blue. This context is 2 of the 1/10 pieces of ribbon is purple and 4 are blue. It's a different context. This is actually a kindergarten story type with whole numbers, where we talk about both addends unknown, but it still exists in the upper elementary, just the numbers change, the fractions and decimals. You want to do the same thing with decomposing fractions, which will help unlock these flexible strategies as they begin calculating flexibly with the numbers. So you can see how the pattern emerges, right? It went 6/10, 5/10, 4/10, 3/10, 2/10, 1/10, 0/10, while the other option went 0, 1/10, 2/10, up to 6/10. So you have that pattern. So I was doing a training today. I'm in New York today. I live in New Hampshire, but I'm in New York doing training all day, every day this week with educators. We did whole numbers this morning, and that being able to see that pattern emerge, and then we can connect that to writing it just abstractly with the numbers, and you see those patterns. It can help us so much in being able to understand the various possibilities. And some of the participants today had built their possibilities and they weren't in random order, but they had partnered together, like the 2/10 and 4/10, and then the 4/10 and the 2/10, like this, right? And that's awesome, right? This is part of the exploration. But when they were done, I had said, how do you know you found all the possibilities? Right? So but how would you prove you know all the possibilities? Well, if you do it systematically, that pattern, you come to the end. There's no doubt you found them all. You're not left wondering, did I not think of something? Right? It's that systematic way, so that pattern emerges. And that's all about patterns with numbers and shapes, right? So so there you go.